Think for a moment about everything your body does for you without your conscious awareness. The steady rhythm of your heart, the expansion and contraction of your lungs, the intricate dance of hormones and signals that keep your internal environment balanced. These systems operate continuously, maintaining life without requiring your attention. But there is one system that does require your attention, one type of tissue that quietly depends on your choices, on your movement, on what you provide it each day. Most people never think about this tissue until they begin to notice its absence. A stairway that once felt easy now requires effort. A grocery bag that was once light now feels heavy. A chair that was simple to rise from now demands preparation. The change is gradual, almost imperceptible, until one day you realize that something has shifted. What if this gradual change is not what it appears to be? What if the slow loss of physical capacity is not simply time passing, but something more specific, more understandable, and more within your influence than you have been led to believe? You are listening to the Longevity Library, where we archive the wisdom of healthy aging. The architecture of longevity. Understanding how the body maintains itself across time. There is a question that eventually arrives in every thoughtful life, usually somewhere in the middle years, when the body begins to behave in ways that seem unfamiliar. The question is simple, though its implications are not. Why do some people remain vigorous well into their later decades, while others decline much earlier, even when both appear to follow similar paths? The answer, as research gradually reveals, has less to do with luck or genetics alone than with a series of daily decisions that accumulate across a lifetime, shaping the body's internal environment in ways that either support or undermine its natural capacity for maintenance and repair. Consider for a moment how the body manages itself during its younger years. In the teens and 20s, the systems that build and regenerate tissue operate at high efficiency. A period of inactivity followed by a few days of movement restores lost ground. Meals are processed with precision, nutrients directed where they are needed, waste products cleared without accumulation. The body behaves as though designed for resilience, capable of absorbing considerable variation in lifestyle without obvious deterioration. Then, gradually, this efficiency begins to shift. Not suddenly, not dramatically, but imperceptibly, like the lengthening of shadows in late afternoon. The same habits that once produced no visible consequence begin to leave traces. Recovery takes longer. Energy fluctuates. The margin for error narrows. This is not a story of decline so much as it is a story of changing rules. The body at 50 does not operate by the same principles as the body at 20. The cellular mechanisms that once hummed along automatically now require more conscious support. The systems that maintain balance now benefit from deliberate attention. Understanding this transition, and learning to work with it rather than against it, forms the foundation of what might be called skillful aging, the living architecture of the human body. To understand how the body changes across decades, it helps first to appreciate what the body actually is. Not in the abstract sense of flesh and bone, but as a living, working system of extraordinary complexity. The human body contains roughly 37 trillion cells, each one a tiny factory carrying out thousands of chemical reactions every second. These cells organize themselves into tissues, tissues into organs, organs into systems that communicate constantly through signals carried by blood, by nerves, by chemical messengers that travel microscopic distances to deliver their instructions. At the center of this vast network sits a type of tissue that receives far less attention than it deserves. Skeletal muscle, the tissue most people associate with movement and strength, actually serves functions that extend far beyond the mechanical. Muscle tissue makes up approximately 40% of total body weight in a healthy adult, making it the largest organ system by mass. But its role in overall health has little to do with its size and everything to do with its metabolic activity. Every muscle cell functions as a miniature processing plant. When food is consumed, particularly food containing carbohydrates, the digestive system breaks these complex molecules down into simple sugars that enter the bloodstream. This rising blood sugar triggers the release of insulin, a hormone that acts as a key, opening cellular doors to allow sugar to enter. Muscle cells possess an enormous capacity to accept this sugar, pulling it out of circulation and storing it as glycogen, a compact energy reserve that can be mobilized during physical activity. This process, repeated countless times across every day of life, represents one of the body's most fundamental regulatory mechanisms. When muscle tissue is abundant and metabolically active, blood sugar rises modestly after meals and returns to baseline efficiently. When muscle tissue diminishes, the same meal produces a higher and more prolonged spike in blood sugar, requiring more insulin to achieve the same result. Over time, this pattern can lead to a condition where cells become less responsive to insulin's signal, requiring still more insulin to manage the same sugar load. The relationship between muscle and metabolism extends beyond sugar handling. Muscle tissue releases signaling molecules during and after activity that travel through the bloodstream to influence fat cells, liver cells, and even brain cells. These signals coordinate metabolic activity across the entire body, telling fat cells when to release stored energy, telling the liver when to produce glucose, telling the brain when energy supplies are adequate. A body with healthy muscle tissue operates as an integrated system. A body losing muscle tissue gradually loses this integration, and the various organs begin working with less coordination than they once did. The natural history of tissue loss. The gradual reduction in muscle mass that accompanies aging has been given a medical name, sarcopenia, though naming it does not explain it. Researchers studying this process have identified several distinct mechanisms that contribute to tissue loss. And understanding these mechanisms reveals why the process is not simply inevitable, but rather responsive to specific interventions. One of the most significant factors involves a change in how muscle cells respond to dietary protein. In younger bodies, consuming a meal containing protein triggers a predictable increase in muscle protein synthesis, the process by which cells build new structural proteins. This response is efficient and robust. In older bodies, the same protein meal produces a blunted response. The cells do not seem to receive the signal as clearly, or they receive it but do not amplify it as effectively. Researchers call this condition anabolic resistance, and it appears to be a central feature of age-related muscle change. Several factors contribute to this resistance. Blood flow to muscle tissue may diminish slightly with age, reducing the delivery of amino acids from digested protein. The receptors on muscle cells that detect these amino acids may become less sensitive. The intracellular signaling pathways that translate amino acid presence into protein synthesis may operate with reduced efficiency. None of these changes alone would produce significant effect, but together they shift the balance from maintenance toward gradual loss. Hormonal changes add another layer to this picture. Testosterone, growth hormone, and estrogen all support muscle maintenance through various mechanisms. As circulating levels of these hormones decline with age, the anabolic signals reaching muscle tissue weaken. This reduction is not catastrophic in isolation, but it contributes to the overall shift in balance between building and breaking down. Inflammatory status also plays a role. The aging process is accompanied by a mild increase in inflammatory signaling throughout the body, driven partly by changes in fat tissue, partly by cumulative exposure to various stressors, and partly by changes in immune function. These inflammatory signals, even at low levels, interfere with the pathways that promote muscle building while simultaneously accelerating protein breakdown. The result is a metabolic environment tilted slightly toward degradation rather than maintenance. Physical activity patterns compound these effects. Muscle tissue operates on a principle of use-dependent preservation. When muscles are regularly challenged with load, whether through lifting, carrying, pushing, or pulling, the body receives a signal that this tissue is necessary and should be maintained. When activity declines, that signal weakens, and the body, always efficient, begins to reallocate resources away from tissue that appears unneeded. The molecular language of building. To understand why certain foods and activities support muscle maintenance more effectively than others, it helps to look more closely at the molecular events that occur when protein is consumed. Dietary protein consists of long chains of amino acids linked together. During digestion, these chains are broken down into individual amino acids and small peptides that enter the bloodstream and circulate to tissues throughout the body. Among the 20 amino acids used by human cells, 9 are classified as essential, meaning they cannot be synthesized internally and must be obtained from food. All 9 are necessary for tissue maintenance, but one in particular plays a special role in signaling. Leucine, one of the branched-chain amino acids, functions not only as a building block, but also as a molecular signal that activates the cellular machinery for protein synthesis. When leucine concentrations rise in the bloodstream following a protein-containing meal, they trigger activation of a complex intracellular pathway often referred to by researchers as the mechanistic target of rapamycin, or mTOR. This pathway functions as a central control switch for cellular growth and maintenance. When activated, it instructs the cell to increase protein production, to build new structures, to grow. When inactive, the cell remains in a maintenance mode, repairing damage but not adding new tissue. The relationship between leucine and this pathway helps explain why not all protein sources are equivalent for muscle support. Foods that provide leucine in sufficient quantity and in balance with other amino acids trigger a stronger anabolic response than foods that provide protein without adequate leucine. This is not simply a matter of total protein content, but of the specific amino acid profile. Research examining this relationship has found that older adults generally require a higher leucine concentration per meal to achieve the same mTOR activation seen in younger individuals, where a younger person might need only modest leucine to trigger protein synthesis. An older person may need approximately 2.5 to 3 grams at a single meal to overcome anabolic resistance and initiate building. Foods that support maintenance. Understanding these mechanisms allows for more informed choices about which foods to include in a daily pattern. Among protein sources available to most people, some provide more efficient support for muscle maintenance than others. Eggs represent one of the most thoroughly studied examples. The protein in eggs is often used as a reference standard against which other proteins are compared, because its amino acid profile closely matches human requirements. A single large egg contains approximately 6 grams of protein, with about half a gram of leucine. More importantly, eggs provide this protein in a form that is highly digestible and readily utilized. The yolk, which for decades was often discarded due to concerns about cholesterol, actually contains nutrients that support protein utilization. Vitamin D, present almost exclusively in the yolk, plays roles in muscle function and protein synthesis. Choline supports cell membrane structure and signaling. Various lipids in the yolk may enhance the delivery of amino acids to muscle tissue. Research comparing whole eggs to egg whites has found that whole eggs stimulate muscle protein synthesis more effectively than whites alone, even when total protein content is matched between conditions. Dairy products offer another valuable source of muscle-supporting nutrition. Greek yogurt, In particular, provides concentrated protein with a favorable leucine profile. A 6-ounce serving delivers approximately 15 grams of protein and 1 gram of leucine, making it a practical complement to other protein sources. The fermentation process involved in yogurt production may also enhance digestibility for some individuals. Fish and lean meats provide complete proteins with ample leucine content. A 3-ounce serving of chicken breast contains roughly 21 grams of protein and 1.5 grams of leucine. Similar portions of fish provide comparable amounts. The variety across these sources ensures that individuals can choose according to preference and tolerance while still meeting nutritional needs. Plant proteins, while generally lower in leucine than animal sources, can be combined strategically to achieve adequate intake. Beans, lentils, tofu, and quinoa all contribute protein. And when eaten in combination with smaller amounts of animal protein or with careful attention to variety, they can support muscle maintenance effectively. The timing of nourishment. Beyond the question of what to eat lies the question of when. Research examining protein distribution across the day has revealed patterns that may enhance or diminish the effectiveness of any given amount of protein. Traditional eating patterns in many cultures concentrate protein intake heavily at the evening meal, with breakfast providing minimal protein and lunch providing moderate amounts. While this pattern does not prevent muscle maintenance entirely, it may not be optimal for older adults. Each protein-containing meal triggers a period of elevated muscle protein synthesis lasting several hours. When protein is concentrated in a single large meal, only one such period occurs daily. Spreading protein across 3 meals creates 3 distinct periods of elevated synthesis, potentially resulting in greater cumulative protein deposition over 24 hours. Studies examining this distribution effect have found that older adults consuming protein evenly distributed across breakfast, lunch, and dinner achieve higher rates of muscle protein synthesis than those consuming the same total protein but concentrated at a single meal. The practical implication involves ensuring that each meal contains approximately 25 to 30 grams of high-quality protein, rather than relying on a single large protein serving at day's end. Breakfast presents a particular opportunity, as many traditional breakfast foods provide minimal protein. Adding eggs, Greek yogurt, or other protein sources to the morning meal can shift daily distribution toward a more supportive pattern without requiring dramatic changes to lunch and dinner. The role of movement. Nutrition alone, no matter how carefully optimized, cannot fully support muscle maintenance without the complementary stimulus of physical activity. The relationship between movement and muscle operates through mechanisms that nutrition cannot replicate. When muscles are challenged with load, whether through lifting weights, performing bodyweight exercises, or engaging in daily activities that require effort, they experience mechanical tension. This tension, applied across muscle fibers, triggers a cascade of signals that prepare the tissue for adaptation. Blood flow to the active muscles increases, delivering oxygen and nutrients while removing waste products. The muscle cells become temporarily more sensitive to anabolic signals, meaning that any protein consumed during this period is more likely to be directed toward building than toward other fates. This heightened sensitivity persists for a period after activity, typically lasting several hours. During this window, the muscle is primed for growth, receptive to the amino acids that will serve as building materials. Consuming a leucine-rich meal within this period amplifies the synthetic response substantially compared to consuming the same meal without prior activity. The type of activity matters less than the fact of loading. Resistance exercises, those that require muscles to work against resistance, provide the most direct stimulus for muscle maintenance. This includes movements like squats, lunges, pushes, and pulls, whether performed with weights, resistance bands, or simply against gravity. The key variable is effort, not equipment. Muscles respond to challenge, and challenge can be created in many ways. Walking, while valuable for cardiovascular health and daily energy expenditure, provides less stimulus for muscle maintenance than resisted movement. This does not mean walking lacks value, only that it serves different purposes. A complete approach to physical activity includes both the sustained moderate movement of walking and the briefer, more intense efforts of resistance work. The daily accumulation of movement. Beyond structured exercise sessions lies another dimension of physical activity that receives less attention but may be equally important. Non-exercise activity thermogenesis, a term researchers use to describe all the movement that occurs outside formal exercise, encompasses walking to the mailbox, standing while on the phone, climbing stairs, gardening, housework, and countless other small movements that punctuate daily life. This diffuse activity, accumulated across waking hours, provides continuous low-level stimulation to muscles and metabolic systems. Research using activity monitors has found that individuals who break up sitting time with brief standing or walking periods maintain better insulin sensitivity than those who sit for prolonged stretches, even when total exercise time is similar between groups. The mechanism involves the frequent activation of muscles, particularly the large muscles of the legs and back, which when contracted briefly improve glucose uptake and maintain metabolic responsiveness. These microbursts of activity, too small to be noticed as exercise, nevertheless signal the body that movement is a normal part of daily existence. For older adults, incorporating more movement throughout the day, independent of structured exercise, supports muscle maintenance by maintaining metabolic flexibility. Simple strategies include standing during phone calls, taking brief walking breaks each hour, parking slightly farther from destinations, and choosing stairs when available. Each individual choice is trivial, but their cumulative effect across weeks and months is not. The restoration of sleep. The work of building and maintaining tissue does not occur primarily during activity, but during rest. Sleep, particularly the deep, slow-wave stages, represents the period when the body directs resources toward repair and regeneration. During deep sleep, the pituitary gland releases growth hormone, one of the body's primary anabolic signals. This hormone stimulates protein synthesis, mobilizes fatty acids from storage for energy, and supports the repair of tissues damaged during daily activity. The growth hormone released during sleep cannot be replaced by any nutritional strategy or exercise protocol. It is a unique contribution of rest. Sleep also regulates cortisol, a hormone with complex effects throughout the body. Cortisol follows a daily rhythm, typically highest in the morning to support awakening and lowest at night to permit rest. When sleep is disrupted or insufficient, this rhythm flattens, and cortisol levels may remain higher than optimal during evening hours. Elevated cortisol promotes protein breakdown and can interfere with the anabolic processes that would otherwise occur during sleep. Research examining sleep restriction has found that even partial sleep deprivation increases markers of muscle breakdown and reduces next-day sensitivity to dietary protein. This means that poor sleep not only fails to support repair, but actively undermines the effectiveness of subsequent nutrition. A person eating an optimal diet and exercising regularly may still struggle to maintain muscle if sleep is chronically insufficient. The practical implications involve prioritizing sleep as a component of health rather than treating it as optional downtime. 7 to 9 hours per night, with consistent timing and attention to sleep environment, provides the foundation upon which other efforts depend. Dark rooms, cool temperatures, and the absence of screens before bed all support the natural progression into deep sleep. The liver's role in protein economy. Among internal organs, the liver plays a particularly important role in protein metabolism, though its contributions often go unrecognized in discussions of muscle health. Every amino acid absorbed from the digestive tract passes through the liver before entering general circulation. The liver monitors amino acid levels, removes those that are excessive, converts some to other compounds, and releases the remainder for use by peripheral tissues. The liver also produces many of the proteins that circulate in blood, including albumin, which helps maintain fluid balance and transports various substances. When liver function is compromised, whether by fat accumulation, inflammation, or other factors, these regulatory processes become less efficient. Non-alcoholic fatty liver disease, a condition in which fat accumulates within liver cells, affects a significant portion of the adult population. This condition often develops without obvious symptoms, but can impair the liver's metabolic functions. Research suggests that fatty liver reduces the efficiency with which dietary amino acids are directed toward muscle protein synthesis, potentially contributing to anabolic resistance. Factors that support liver health include limiting added sugars, particularly fructose from sweetened beverages and processed foods, which the liver must process and which can contribute to fat accumulation when consumed in excess. Reducing alcohol consumption allows the liver to focus on its metabolic functions rather than detoxification. Including vegetables, particularly leafy greens and cruciferous varieties, provides nutrients that support liver function without adding metabolic burden. Inflammation as a hidden factor. Low-grade inflammation represents another influence on muscle maintenance that operates beneath the level of obvious symptoms. Unlike the acute inflammation of injury or infection, which serves a protective function and resolves when its work is done, chronic low-grade inflammation persists quietly, gradually affecting multiple systems. This inflammatory state is driven by several factors common in modern life. Excess fat tissue, particularly visceral fat stored around internal organs, releases inflammatory signaling molecules. Processed foods, especially those containing refined oils and added sugars, can promote inflammatory responses. Poor gut health may allow bacterial fragments to enter circulation, triggering immune activation. Cumulative exposure to various environmental stressors adds further burden. These inflammatory signals, even at low levels, interfere with muscle maintenance through multiple pathways. They activate cellular mechanisms that break down protein, while simultaneously inhibiting the pathways that build new tissue. They can reduce appetite or alter food preferences in ways that reduce protein intake. They may contribute to fatigue that discourages physical activity. A study published in Gerontology Research found that older adults with higher inflammatory markers lost muscle at nearly double the rate of those with lower inflammation, even when protein intake was similar between groups. This suggests inflammation independently contributes to tissue loss beyond its effects on nutrition and activity. Dietary patterns that emphasize whole foods, vegetables, fruits, and healthy fats tend to be associated with lower inflammatory markers. Omega-3 fatty acids from fish or fish oil have demonstrated anti-inflammatory effects. Plant compounds from colorful vegetables and herbs provide antioxidants that neutralize some of the oxidative stress accompanying inflammation. Reducing processed foods removes common dietary drivers of inflammatory responses. The question of micronutrients. Protein often receives the most attention in discussions of muscle health, but it does not work alone. The enzymatic reactions that convert dietary amino acids into structural proteins require various vitamins and minerals as cofactors. Without adequate supplies of these micronutrients, even optimal protein intake cannot be fully utilized. Vitamin D deserves particular attention because deficiency is common and because its role in muscle function is well established. Vitamin D receptors exist on muscle cells, and adequate vitamin D levels appear necessary for optimal protein synthesis and muscle performance. Research has consistently found associations between low vitamin D and reduced muscle strength, as well as increased fall risk in older adults. Magnesium participates in hundreds of enzymatic reactions, including those involved in protein synthesis and energy production. It supports the structural integrity of proteins and helps regulate muscle contraction and relaxation. Deficiency can impair muscle performance and may limit the adaptive response to training. Zinc plays roles in protein structure and in the signaling pathways that regulate muscle growth. It supports immune function, which becomes particularly relevant as the relationship between inflammation and muscle loss becomes clearer. B vitamins, particularly B6 and B12, function in amino acid metabolism and energy production. These nutrients are best obtained from food sources, where they occur in complex with other compounds that support their utilization. Leafy greens provide magnesium. Fatty fish and eggs provide vitamin D. Meat and shellfish provide zinc. Whole grains and legumes provide B vitamins. For individuals with documented deficiencies, supplementation may be appropriate, but food sources remain the foundation. Strength across the lifespan. A persistent misconception holds that muscle-building efforts are futile after a certain age. Research examining this question has repeatedly contradicted this view. Studies have placed previously sedentary adults in their 70s and 80s on simple resistance training programs and documented significant strength gains and measurable muscle growth within a few months. The capacity for adaptation persists throughout life. While the rate of response may differ from that seen in younger individuals, the direction of change remains positive with appropriate stimulation. Muscle tissue retains its fundamental plasticity, responding to mechanical load and amino acid availability regardless of chronological age. This adaptability means that interventions begun at any point can alter the trajectory of age-related change. Even individuals who have already experienced significant decline can reverse some portion of that loss and regain functional capacity. The combination of resistance exercise and adequate protein nutrition represents the most reliable approach for achieving these improvements. The functional implications extend beyond abstract measures of muscle mass. Strength in the legs predicts the ability to rise from a chair without assistance, to climb stairs, to maintain balance during walking. Strength in the arms predicts the ability to carry groceries, to open containers, to perform household tasks. These capabilities, often taken for granted when present, become profoundly meaningful when they begin to diminish. The integration of daily choices. Considering all the factors that influence muscle maintenance across decades might seem overwhelming, but the practical reality is simpler than the sum of its parts. Each day presents opportunities to make choices that, over time, shape the body's internal environment in directions that either support or undermine its natural maintenance systems. Morning meals can include protein sources that provide leucine in amounts sufficient to trigger synthesis. Midday movement can break up sitting time and maintain metabolic responsiveness. Evening meals can continue the pattern of adequate protein while including vegetables that support overall health. Resistance exercise, performed 2 or 3 times weekly, provides the mechanical stimulus that primes muscles for growth. Sleep, prioritized and protected, allows repair processes to complete their work. None of these individual choices determines outcome by itself. Each is simply one thread in a larger fabric. But woven together across weeks and months, they create a pattern of support that the body recognizes and responds to. The body does not require perfection. It responds to consistent direction, to the cumulative signal of repeated choices. The body is a system, Perhaps the most useful way to think about muscle health is not as a separate concern, but as one aspect of whole body function. The same factors that support muscle also support other systems. The protein that provides amino acids for muscle also provides them for immune cells, for enzymes, for structural proteins throughout the body. The activity that stimulates muscle also challenges the cardiovascular system, maintains bone density, supports balance and coordination. The sleep that permits muscle repair also allows brain clearance of metabolic waste, consolidates memory, regulates mood. This integration means that attention to muscle health is not an isolated project, but an entry point for broader health maintenance. The choices that preserve muscle simultaneously support the heart, the brain, the bones, the metabolic systems that coordinate energy use throughout the body. There is no competition between these goals. They align. Research following large populations over time has found that individuals maintaining higher muscle mass experience lower rates of cardiovascular disease, better glucose control, reduced fracture risk, and slower cognitive decline. These associations persist after controlling for many other variables, suggesting muscle itself exerts protective effects, not because muscle tissue is magical, but because it reflects and supports the metabolic health of the entire organism. The question of independence, underlying all discussion of muscle health, all consideration of protein timing and exercise frequency and sleep quality, is a more fundamental concern. The preservation of physical capability is intimately connected to the preservation of independence, the ability to live in one's own home, to move through the world without assistance, to perform the ordinary tasks of daily life without depending on others. These capabilities depend on maintaining adequate strength and function. Loss of muscle does not happen suddenly. It accumulates gradually, each small decrement barely noticeable until a threshold is crossed and a task that was once simple becomes difficult. Rising from a low chair, carrying a bag of groceries, climbing a flight of stairs, walking across a parking lot. Each of these activities requires a certain minimum level of strength. Below that threshold, assistance becomes necessary. The difference between independence and dependence often comes down to relatively small amounts of muscle mass and strength. A person who can rise from a chair without using arms remains independent in that function. A person who cannot may need help with dozens of daily tasks. The margin between these states is not large, and it is within reach of most people to maintain or regain. This is not about preparing for some distant future. It is about the ongoing process of living in a body that changes across time and responding to those changes with attention and intention. The choices made today shape the capabilities available tomorrow, next month, next year. The body remembers what it is asked to do and what it is given to work with. It responds accordingly. The calm path forward. There is no need for urgency or alarm in considering these matters. The changes that occur across decades unfold slowly, offering countless opportunities for course correction along the way. Missing a day of exercise matters not at all. Missing a week is easily recovered. Even longer periods of inattention can be addressed when awareness returns. What matters is direction, not perfection. A pattern of choices that generally supports muscle maintenance will produce better outcomes than a pattern that generally does not, regardless of occasional deviations. The body is forgiving within reason. It asks not for flawless performance, but for consistent support. The research on muscle health, when viewed from sufficient distance, reveals a simple truth. The body maintains itself best when it is regularly challenged with load, adequately supplied with complete protein, allowed sufficient rest for repair, and protected from the cumulative burden of inflammation and metabolic stress. These conditions are not difficult to provide. They require only awareness and intention, applied consistently across time. for those in the middle years. The choices made now shape the experience of later decades. For those already in later decades, the capacity for positive change remains. The research is clear on this point. Adaptation is possible at any age. The body retains its ability to respond to appropriate signals. It waits only for those signals to be provided. The single most important takeaway from everything we have explored together is this. The body maintains itself best when it is regularly challenged with load, adequately supplied with complete protein, allowed sufficient rest for repair, and protected from the cumulative burden of inflammation and metabolic stress. These conditions are not complicated to provide. They require only awareness and intention, applied consistently across time. If these ideas have prompted reflection, if they have raised questions about your own patterns or possibilities, we invite you to share those thoughts in the comments. What has been your experience with the changes we have discussed? What questions remain? The conversation continues there. If you would like to explore further, you will find other recordings in this library addressing related questions about strength, metabolism, and the art of living well across decades. Consider subscribing so that new wisdom finds its way to you. This is the Longevity Library. Listen, learn, and live longer.